I welcome you in fifth part of my video in which I will explain about R-square, R-square adjusted and R-square predicted. So R-square measures the proportion of total variability explained by the model. It means that we have three terms in the model A, B and C. And this R-square explains that how much these three terms have explained the variability in the response variable. So how we will calculate R-square? We will calculate by dividing SS model by SS total. Now what is SS model? If we subtract the sum of square of error from sum of square of total, we got sum of square of the model. In short, we will have to add all of the sum of squares except sum of square of the error and we will get SS model. So we got 0.9661. It means that 96.61% variability in our response variable H rate has been explained by the factor A, B and C. However, there is a problem with the R-square is that the value of the R-square increases as we are continue adding the terms in the model. It doesn't see that whether the term is significant or insignificant. To tackle this problem, we find our adjusted R-square. It accounts that if we add any insignificant term in the model, our R-square adjusted value decreases. So that's why the formula is 1 minus sum of square of the error divided by degree of freedom of the error, then divided by sum of square of the total divided by degree of freedom total. So we got 93.64. You can see that this value is less than R square. It means that the terms A, B and C, they explain 93.64% variation in our response variable. We use another term R square for prediction based upon predicted error sum of squares, which measures that how well the model will predict the new data. So it explained that this indicate it 0.8644, that 86.44% variability in the new model can be explained by the model that we have made. Now to make the confidence interval for the coefficients, for the regression coefficients, we need SE of the beta, standard error of the coefficients. So as we have the orthogonal model, so we have the same standard error for all of the term. It can be calculated as by dividing the mean square error divided by the number of terms we have in the model. We have 16 terms, so I got 11.87 as the standard error. This standard error is used by T 0.025. It has been used because we have alpha is equal to 0.05 in this question. So the alpha has been divided by 2. Alpha is, we got 0.05 divided by 2. That result in 0.025. This 0.025 has been written there as well as it has been written there. So now this standard error of the beta, it comes out to be 11.87 and we write both of them here, and then beta hat and this one beta hat. This is the estimated value. So using these coefficients and then the standard errors, we have formulated the confidence interval at 95% alpha value. These are the low value of the confidence interval. These are the high value of the confidence interval.